Complex numbers. Complex numbers are numbers which are composed of a real value and an imaginary value. They're written in the form a plus bi, where a is the real part and bi is the imaginary part. Imaginary numbers were devised to allow us to work with negatives under square roots. Among other things, imaginary numbers help us describe the solutions of quadratic equations whose graphs, which are parabolas, don't cross the x-axis. So the definition of the imaginary number I is that it is equal to the square root of -1. So for example, if I want to take the square root of a negative number, just take the square root like normal and then put an I on the end of it. So if I want to do the square root of -25, the square root of 25 is 5, and then because of the negative, you put a little I with it. If we need to square an imaginary number, it's the same thing as squaring the square root of -1. And so since a square and a square root cancel each other out, I squared is equal to -1, and that comes up quite a bit. So every time you see an I squared, you can replace it with a -1. So we're supposed to evaluate these expressions, and the first one is an addition problem. Even though they're both in parentheses and it would be tempting to FOIL those, the plus in the middle means we're just adding them, so we just combine like terms. So I can add the 3 and the 2 and get 5, and then add 5i plus 4i and get 9i. You can't combine the 5 and the 9 just like you wouldn't be able to if it was 9x. The second example, we are multiplying, so we need to FOIL. Multiplying first, 3 times 2 is 6. Outside would be 3 times 4i is 12i. Inside, 5i times 2 is positive 10i. And then last will be positive 5 times 4 is 20, and I times I is I squared. Every time you see an I squared, you can completely replace it with a -1. So in the back, what we really have is 20 times -1, which is -20. Now combine like terms. 6 minus 20 is -14. 12i plus 10i is positive 22i. When a fraction has an imaginary number, or a radical for that matter, in the denominator, it's not in the proper form. So to get it in the proper form, we have to multiply the top and bottom of the fraction by the conjugate. This is just the denominator with the middle sign changed. So for example, in this problem, what I'm going to multiply top and bottom by is 2 minus 3i. I only changed the middle sign. If the original had been 2 minus 3i, then I would be multiplying by 2 plus 3i. So the middle sign gets changed. Now on top, distribute the 5, and we have 10 minus 15i. On the bottom, we're going to FOIL. When you do that, you have 4, and then minus 6i. Inside is plus 6i, and last, watch your signs, be really careful. It's positive 3 times -3 is -9, and I times I is I squared. The 6 i's will cancel. Now, this always happens with conjugates, that the outside and the inside always cancel. So you can take a shortcut and skip those if you can remember that, and just do first and last. On the bottom, I have an I squared, which will turn into a -1. So it's going to be -9 times -1 is positive 9. My top stays 10 minus 15i. On the bottom, I have 4 plus 9, which is 13. Once you get it to that stage, you want to look at all three numbers. If all three divide by something, you want to reduce it down. It has to be all three. It can't just be 2 of them. This one doesn't have anything that divides, so it's finished. Now, sometimes textbooks want you to write it in the form a plus bi. And for me personally, I don't mind if you leave the answer the way that I have it here. But if you want to write it in a plus bi form, you just split the fraction up, and you would have 10 over 13 minus 15 over 13i. So for me, either answer is correct there. Okay, let's try another one. This time the conjugate, we change the middle sign, so I'm multiplying the top and bottom by 1 minus 2i. And again, if it had started out 1 minus 2i, we'd have to do 1 plus 2i, top and bottom. Now, on the top, those are not conjugates. We have to FOIL it, and there's no shortcut. The outside and inside won't cancel. So multiplying out the top, we would have 4 minus 8i plus 3i minus 6i squared. The bottom, first, 1 times 1 is 1. Outside and inside will cancel, and then last would be minus 4i squared. My I squareds will turn into negative 1s, so they're completely gone, replaced by negative 1. That will make my 6 on top turn into a plus 6. The 4 on the bottom will turn into a plus 4. Now combining like terms, on top we have 10 minus 5i. On the bottom we have 5. Now looking at all three terms, I see that they all divide by 5, so I have to reduce it down, and we're left with 2 minus just 1i over 1, which you don't need to write. This one's a little bit different, that we only have one term on the bottom, so it's not like you can do a conjugate. What you do about these is you just multiply the top and bottom by I, and that way you'll have an I squared in the bottom, which will turn into a negative 1, and you don't have any more i's in the bottom. On top, let's distribute the I. 4i plus 6i squared. The bottom's going to be 3i squared. Every time we have an I squared, it turns into a negative 1. So now it becomes 4i minus 6 over negative 3. And if we were going to write that in a plus bi form, then we would split the fraction apart, and that would be 4i over negative 3, and then a negative divided by negative would be a positive 6 over 3, and the term with the I is supposed to come second. 6 over 3 is 2, so we'll write 2 minus 4/3 I. And again, for my purposes, this first answer is fine, but if you're in a situation where you have to write it in a plus bi form, this would be the answer. And if you're checking in the back of a textbook, it looks like if you see this and you have this, you might think you got it wrong. But if you'll think about splitting the fraction apart and reducing, it's the same answer. Now, a little review with radicals. The way that this is, we would want to go ahead and break down our radicals. You could do it here at the beginning, or you could do it later, but I'm going to do it at the beginning just for what the next problem is going to be. So I can break down the 12 into 4 times 3, and the 4 is 2 times 2. And so when you have two of the same number, it can come out. That gives me 2 with a 3 left on the inside, minus square root of 3. And then with the 8, it's 2 times 4. 4 is 2 times 2, so a 2 can come out, and a 2 is left on the inside. 3 plus 2 square root of 2. Now I can FOIL. When you multiply with radicals, you multiply outsides with outsides, insides with insides. So first would be 6 square root 3. Outside, positive 4 square root 6. I did my outside numbers together to get 4. I did my inside numbers together to get 6. And then still foiling, we're on inner, so that would be minus 3 square root 3. And last would be minus 2 square root 6. And then the ones that have the same number under the radical we can combine. 6 square root 3 minus 3 square root 3 is 3 square root 3. 4 square root 6 minus 2 square root 6 is 2 square root 6. And then that's as far as you can go with that. So keep all that in mind. Let's do the same problem, but some of the numbers are going to have a negative. So we're kind of going to go through the same process. 12 is 4 times 3. 4 is 2 times 2. So a 2 will come out, a 3 will stay home. But because of the negative under the square root, not only will the 2 be out, it will be 2i square root 3 minus, and then we have a negative under the square root of 3, so an I comes out, and we have square root of 3 like that. Then for the last one, it will be what we had in the previous problem. There's no negative, so there's not an I. So it'll be 3 plus 2 square root 2. Now, one thing I could have done in the previous problem, in the first parentheses, these are like terms. So let's do this one a little bit different way. Either way is fine, but this is just an alternate way. Because these two are like terms I can combine, 2i minus 1i would be just 1i square root 3. And then there's a little less multiplication involved. I'm going to distribute. And remember, outsides with outsides, insides with insides. So first we would have 3i square root 3, and then plus multiply and 2i square root 6. When we solve quadratic equations, we're finding the zeros, and zeros are where the parabola crosses the x-axis. But not all parabolas cross the x-axis. For example, this one, y equals x squared minus 6x plus 11, you can see the parabola, but it never crosses the x-axis. So that means the solutions are imaginary. The parabola is very real, and it does have solutions. It's just that it doesn't cross the x-axis, so that means they're imaginary. We have to use the quadratic formula to solve this. So it says find all solutions and express them in the form of a plus bi. We're going to use the quadratic formula. So x equals negative 4 will be positive, plus or minus the square root of negative 4 squared minus 4 times 1 times 7, all over 2 times 1. Underneath the square root, you end up with a negative 12. Now break down the square root. 4 times 3, 2 times 2, so a 2 comes out, 3 stays in. So 4 plus or minus 2 comes out. Because the 12 is negative, not only does a 2 come out, an I also has to come out. Square root 3 all over 2. Then you look at all three outside numbers. All three of these divide by 2, so we want to reduce it down. If I divide everything by 2, I'm left with 2 plus or minus I square root 3. And that automatically, because the fraction went away, is in the a plus bi form. We could put the I in the back, but sometimes that makes things confusing. So let's just leave it like that. Sometimes you're given a quadratic equation and it's not really in the proper form to use the formula. For example, this first one, we have a fraction with a t on the bottom. There's no t squared. So what you can do about that is just multiply everything by t. Remember, to get rid of fractions in an equation, you multiply by the common denominator all the way across. And that way, the t that's on the bottom of the fraction will cancel. Now we have t squared plus 3t plus 3 equals 0, and we can go ahead from there and do the quadratic formula. A similar problem, 1/2 x squared minus x plus 5. You could do the quadratic formula with these numbers, but probably you don't want to have fractions mixed in with that. So you can multiply everything by 2. That will get rid of our fraction, and we have x squared minus 2x plus 10 equals 0, and then from there you could do the quadratic formula.